Dear attendees, I have no idea how to start a conversation with a crowd, but hi, my name's Philip. I do security research for Cybereason, and I am in the process of losing my voice, so this is not my natural voice, and you get treated to the most sensual version of my talk because of this. This talk is going to be about device guard and a couple of ways to bypass it. A couple of them are going to use VBA, a couple of them are not going to use VBA, and actually most of them are not going to be treated as actual vulnerabilities by Microsoft. But, well, you know, I don't think any real-world attacker will look at this and say, oh, this won't get a CVE, I'm just not going to use it, this is beneath me. They're just going to use whatever is at hand, and I'm going to show whatever is at hand. And, well, if you're one of those really weird CVE fetishists that I have just invented, you will have just this one, I guess, closer to the end. So, to begin with device guard bypasses, let's begin with, well, what the hell's device guard? So, device guard is an application whitelisting feature that was introduced in Windows 10. It's the successor to an older feature called App Locker. Now, whitelisting and device guard in particular try to stop an attacker from running arbitrary code on a machine after they have already gained some kind of access. And this is done by restricting any kind of code that could execute on the machine to only the code that complies with a very specific policy set by the administrator. The policy could be a list of certificates that could sign the code. It could be a bunch of hashes, names, etc. And if you don't comply, you're not trusted and you won't run. Now, this gives us a very wide attack surface because you can basically use everything that's natively available on a Windows machine. You don't need something to be available remotely or to be run with some kind of high privilege. If it's on the machine, you could try to use it to bypass device guard. So to understand what counts as a bypass, we should first understand or at least formalize arbitrary code, which in our case will be the ability to freely interact with the machine, with the OS. And if we can't do anything, if we can't do a thing, it would be because of a privilege constraint. We can ask the OS to give us something and it won't give us, but we need to have the ability to ask. And the most direct way to achieve this, at least on Windows, is just having a process that you control fully, which can be done by being able to allocate and jump to code in the process, or just to call a couple of arbitrary WinAPI or syscalls or whatever. And of course, you could very quickly jump between these two different definitions because you could very easily call a couple of syscalls to allocate code, and you could just allocate a couple of syscalls. Now, this definition was useless if you're not using application whitelisting because an attacker gains access, they gain arbitrary command execution, which is the actual threat model of whitelisting. And arbitrary commands pretty much equal arbitrary code. Why? Because you want to run a piece of malware, you run malware.exe, and that's it. You've gained arbitrary execution. But this equation actually breaks the moment you implement application whitelisting, because suddenly you have to rely only on what's allowed on the machine. Meaning that even if you have some really cool exploit that pops calcs and notepads left and right on your machine, you're going to reach your target machine and think, well, I really want to steal some credentials. I want to run Mimikatz or something like that. But no, you still have notepad or calc, which is much, much less useful for you. And lots of stuff like CNC, credential stealing, and even if you have like this very cool privilege escalation vulnerability that you still need to run actual code for, you still won't be able to use all of that stuff. So this equation of arbitrary commands equal arbitrary code simply breaks. So to be able to bypass this equation, we need to be able to do one of the two things that were in the last slide. Now, even if you've somehow succeeded to take full control of a single process, you could actually lose this capability Because let's say, for example, that you want to implement persistence. Almost all persistent techniques on Windows allow you to run a command. So you're, again, downgraded to calculator. Same thing happens with many sandbox escapes and privilege escalation vulnerabilities. Same thing happens with lateral movement. So even if you somehow have landed in your own process, it's very easy to lose this capability. And you need to have some kind of reliable bypass to be able to run arbitrary code in all of those contexts. So this was a bit about application whitelisting in general. Let's see how it's implemented in DeviceGuard. So the most direct way DeviceGuard is implemented is in respect to PE files. Now, PE files, if they're not in the policy, if they're not compliant with the policy, they simply will not run, and that's it. But it gets a bit more subtle the moment you reach other types of execution on Windows. PowerShell, which normally will allow you to basically access all of .NET's capabilities, which will really easily lead you to arbitrary code, actually still runs scripts if they are untrusted, if they do not comply with the policy. But they're run in what's called a constrained language mode, which basically strips apart all of the fun parts of PowerShell, so you can't really do anything interesting with it. Well, you can do a bit of stuff like use WMI, but it's still not a full-featured PowerShell instance, and you can't really implement stuff like credential stealing. A similar thing happens with ActiveScript engines, which are stuff like the J and VBScript DLLs. Now, these access the operating system pretty much solely through COM objects. And you could use some techniques like .NET to JScript to leverage this access to arbitrary COM objects to arbitrary execution. So what ActiveScript does with DeviceGuard is, if you're running a trusted script, it runs as normal. If you're running an untrusted script, you're actually able to only create COM objects from a very restricted hard-coded list. And the list contains stuff like scripting.dictionary. So this is not very useful. You could, of course, use a hash table, but this really is not what you want as an attacker. So let's take a look what happens pretty much visually when you try to run unsigned.exe. You don't get execution, you just get this pretty blue pop-up with the ability to copy the error to the clipboard, which isn't really useful for an attacker. Now, unlike its predecessor, DeviceGuard is actually trying to be user agnostic, meaning that it doesn't matter if you're an administrator or a regular user. If DeviceGuard is on, it will prohibit you to run untrusted stuff, even as an admin. But an administrator could actually just disable DeviceGuard. So, well, then why just use it as an admin? Because this actually requires you to restart the machine. And it actually throws a very descriptive event log. And this means that you have a very, very strong signal that says something weird happened with DeviceGuard on a specific machine. So if you are implementing whitelisting and specifically DeviceGuard on your network, you shouldn't stop monitoring. You will have less alerts, and this type of alert should really raise your alarms and, fire up your sirens or whatever. So if an attacker has a way to bypass DeviceGuard that even requires administrative privileges, it's still very beneficial because you are able to do this stealthily. You don't need to choose between, do I want to be unable to run arbitrary code or do I want to be caught after a couple of hours? You could actually persist on the network that you're trying to attack. So if we have more of these, we suddenly again force the defending side to monitor a lot of different behaviors, and you're going to be lost in the noise. So let's move on to a couple of actual bypasses. And the first couple are going to be based on VBA, or Visual Basic for Applications. This is the magic sauce, or like the disgusting magic sauce that is behind Office macros. Now, Office macros pretty much easily allow you to reach arbitrary execution because they allow you to use arbitrary when API, meaning that you just supply DLL, supply a function, and you can just use it in the context of a macro. And it also allows you to use COM objects. So again, you could use, you could build a shellcode runner, you could use .NET to JScript. Anyway, it's pretty easy to reach arbitrary execution through VBA. And VBA is not instrumented by device guard, meaning that the moment you run VBA, nothing stops you from importing any kind of functionality that you want. But the naive way to use VBA is not really cool, because you need to do this in a phishing scenario. So if you're already on a machine and you're in a post-exploitation scenario, making the user click something is really not effective, because you've probably already passed that part and you don't really want to, I don't know, bring up a pop-up or anything. So could we actually use macros in a post-exploitation scenario without interacting with the GUI, without any user interaction? And yes, there are a couple of ways to do so. One of the ways is a lateral movement approach. While you can't do some stuff on the local machine, you actually can reach the Office application's DCOM object remotely. And the Office applications, pretty much each and every one's, like Words, Excels, etc., they actually expose a DCOM method that allows you to run macros, meaning that if you're using the lateral movement approach, you could just make the Office application run whatever macro you want. And this is actually even available filelessly, and it will not do anything, and it will not ask the user to do anything. So basically, the thing that everything you need to do is just to create a remote instance of the Office application that you want to abuse. In this case, it's Excel. So I just create the Excel.application object. You then do a bit of WMI registry magic and change a key that will allow you to programmatically inject a macro into an empty document. You create an empty document. You don't save it. You inject the macro from your string into the new Office document, and then you can just run the macro. So we can do this completely filelessly. We never save the file. And if the machine has device guard on the other end, it does nothing to stop us from executing whatever we want in the context of the macro. But the biggest issue with this is that, well, it requires admin. And while I did say that admin is still cool, we should be able to do stuff locally and privileged, because this is much more useful. So to do so, we need to ask ourselves, well, when does Office actually forsake this protected mode thing and just stops asking for user input to run macros? And there are a couple ways. One way is, if you've ever clicked on accept content on a macro, and then reopened the document, you might have noticed that you don't really get the prompt again, and this is because the document is considered trusted, which is documented in the registry. But the way these trusted documents are saved, pretty much it confused me for a bit, because there was this bit of encoded data that you needed to craft to strongly identify the document. And I've recently discovered, like yesterday, that the annoying part, it just gets ignored. So I was just too lazy to reverse engineer and discover that it's absolutely meaningless. So I've actually used another approach, which is trusted locations. Each Office application actually maintains a list of trusted locations from which all documents will be opened without protected mode, because, well, you know, you can trust it. Trusted's in the name. But the supposed defense against just running from a trusted directory is that all the default trusted directories are writable by admins. So if we, for example, have this ACC Wiz directory, you can see that it's not writable by the regular user group. So here you can see how these are maintained in the registry. And you just see that you have like Office 16, MS Access, security, trusted locations, and the very descriptive location too. And you see that you have like a small description and the path of your trusted directory. But you might notice that even if the directory itself is protected against non-admin users, you have a bit of a problem here, which is, well, everybody could just create their own trusted directory. So we're in a post-exploitation scenario, meaning that we could basically run any command. And this resides in HK current user, meaning that the current user can write and maintain new trusted directories. So all we need to do is to again do some WMI magic, this time done locally because PowerShell actually permits WMI operations even in constrained language mode, so we don't need some kind of signed script to do whatever I'm doing here. So I'm just adding ctemp to the list of trusted directories that are used by Microsoft Access. And then I don't need to worry about protected mode anymore because, well, it's trusted. It just runs. All I need to do is maybe add this small / embedding parameter that prohibits access or any Office application from creating a GUI, so we don't get this weird pop-up because this really isn't stealthy. And of course, my macro runs Notepad because I just had a little rant about attackers only using Notepad. All right, so now we have a couple of ways to use VBA to basically break device guard, but application whitelisting is hard, and if you've taken the effort of like modernizing your network and really prohibiting lots of weird stuff, maybe just stop using macros altogether. Maybe even block VBE7, the Office macro engine, explicitly just block it in your policy, so the library will never run and nobody will ever be able to run an Office macro, or at least a VBA macro. So let's find a couple of non-VBA based bypasses. And well, we've stopped using macros, so let's start using macros. Excel actually has another older macro system, which is called Excel4 or XLM macros. Now, this was introduced in 92, which is coincidentally my birth year, so it's as old as I am. And it's actually implemented in Excel.exe itself. Now, this thing actually allows you to use arbitrary Windows API by two internal functions. One is call, that simply gets the name of a DLL, the name of a function, and like a weird parameter string, and then the actual parameters to the function. And register, which allows you to actually use data that is in Excel cells to call an arbitrary Windows API function. But this whole thing is actually implemented inside of like an Excel sheet, which is really, really hard to look at or write. Now, I at first was unable to use it to bypass device guard because of a couple of constraints that I had with actually using the call and register functions. So I was able to like run a new process, and I was able to run a COM scriptlet that runs like VBScript or JScript. But as we've said, run a new process instrumented by device guard won't run. Run a scriptlet. We already have this COM filtering. We have nothing. So a couple of guys named Stan and Peter from Outflank did a really, really cool DerbyCon talk this year. And they actually showed that you can run x86 shellcode using Excel4 macros. Now, you can't really use 60-bit shellcode, 64-bit shellcode, because basically I'll just continue. All right, so you can actually use 64-bit shellcode because you have like a couple of data types that you can give to the Excel4 macro. to say, well, this argument is of this type, and there is no 64-bit type, so you just can't cram your pointers in there, and this is a bit problematic for shellcode. But most of Office is still somehow 32-bit, even on 64-bit systems, so this will be okay for most environments. And it looks like this. So you basically use the register function to register like the usual suspects of shellcode running. So you have stuff like virtual alloc, write process memory, and create thread. And you actually save your raw shellcode as a sequence of bytes inside an Excel cell. So it's this weird value thing on the first row, because Excel does not know how to display long byte arrays in a single cell. It knows how to store them and knows how to put them into the macro, but it still won't display it. But again, we have this annoying enable content thing, and we're running in protected mode. But we already know how to circumvent protected mode. So we could use lateral movement, create the Excel application COM object, just copy over our malicious macro, and just execute run auto macros, which will execute our shellcode, and again pop a calc or notepad or whatever, because that's the only thing that we need as attackers. And the trusted directory trick works exactly the same. It doesn't matter if you have a VBA macro or an XLM macro in your file. If you add a trusted location and run your document from the trusted location, no protected mode, your whatever macro will just run. So the benefit that you have over VBA macros is that Excel4 macros are actually implemented in Excel.exe. Meaning that you have a choice. Either you throw away Excel and actually block it in the policy, or you leave a huge hole in your device guarded machine, because, well, you can't just block off only the one part of Excel that does this, because it's in the main executable. So if you have Excel, you have pretty much a device guard for every day. Yeah. So we're done with macros for today. Sort of. So let's look at a different category of bypasses, which abuses ActiveScript. Now, ActiveScript is a sort of generic specification for Windows scripting engines, and it's what's behind stuff like JScript and VBScript. And the specification allows you to basically build your own scripting engines, which will then be able to be used just like VBScript or JScript. Or build new hosts that will be able to be scripted by these things. And if you're compliant with the specification, every single thing that, every single other piece of software that's compliant with ActiveScript is supposed to be able to use it. And it has already been the target of a couple of different bypasses, mostly called squibbly something, that you might have seen. Not necessarily used as device guard bypasses, but as interesting execution techniques. Now, the way ActiveScript is actually implemented is by two main types of components. One is the active scripting engine, which is simply an implementation of a program of some scripting language that exposes the specific ActiveScript interfaces that are needed by the other component, which is the scripting host. Now, the scripting host is actually the thing that, for example, teaches VBScript what HTML is when it's run in the context of Internet Explorer, because you run it in Internet Explorer, which is already a mistake, but suddenly you can modify DOM stuff, and when you run VBScript under CScript, this whole thing is gone. So what the scripting host does, or one of the things the scripting host does, is provide some objects and methods to the scripting engine itself, so it could actually script a different application or its host application. Now, there are a couple of different scripting hosts and engines that are natively available on Windows. So in terms of hosts, you have stuff like W or CScript.exe. You have strobj.dll, which is actually the engine behind COM scriptlets. You have MSXML 3 and 6 that are the engines behind XSL stuff. And you have mshtml.dll, which is basically the Internet Explorer HTML engine. And in terms of scripts, you have JScript, which is JavaScript. You have VBScript, and you have JScript9.dll, which is another JavaScript engine, because why not? Now, the way Device Guard works in ActiveScript is, as I've said before, it blocks you from creating arbitrary COM objects. It only lets you to create something that's compliant with a very specific hard-coded list of pretty useless, at least to attackers, stuff. And the way COM objects get filtered is it pretty much goes like this. So let's say I want to create the notorious wscript.shell object using JavaScript. So I do new ActiveX object. Under the hood, our scripting engine tries to translate this prog ID, this friendly name, into a GUID-like class ID, which is then sent over to our scripting host. And the scripting host calls a method called isClassAllowed, which under the hood checks against a library called wodp.dll, which is the user mode device guard implementation, which actually contains the hard-coded list that I spoke about before. And if our class ID, if our GUID is a part of the list, we get like the is allowed flag up, and we can create it whatever we want. And if this is not a part of the whitelist, and we're not running in the context of a trusted script, meaning like a signed script, then class creation will simply fail, and you won't be able to do whatever you wanted. Now, what happens when you just don't have this isClassAllowed function? Well, the scripting engine will just say, let's create the thing anyway. So the simplest way to bypass this whole thing is to find a scripting host that does not have this isClassAllowed function implemented, meaning it's not enlightened by device guard. So one such thing is the ActiveScript event consumer, which is a WMI class that you might know from like the classic WMI persistence method. Now it's actually implemented in its own exe in the strconst.dll, and it implements its own scripting host that is not dependent on any of the others that I've shown in the previous slides. And it's not instrumented by device guard, meaning that the moment you run a script in its context, no matter what engine it runs under, it will simply not check if a COM object is whitelisted or not, and it doesn't really matter if your code is signed or not. So the only shortcoming is that it's only available as admin, but the way to implement this is actually exactly the same as the implementation of WMI persistence. So you have our consumer, which is represented by a class, and you just give it the text of the script that you want to run, and then you create some kind of trigger event called WMI event filter, which in this instance just says, well, let's run let's like trigger every time that Notepad runs. And then you bind those two things, and then every time the event triggers, you have the consumer triggering. So every time I run Notepad, I also run CMD because I'm using this wscript.shell run cmd.exe script. And wscript.shell is supposed to be not allowed by device guard. So this is one way to do this. Another way is to use XSL or XSLT transformations, which are basically a file format that describes how to transform an XML from one format to another. And of course, it somehow supports embedded scripting and also supports ActiveX. And this scripting host is simply, again, not instrumented by device guard, meaning that if you're able to run an XSLT transform somehow, you've bypassed device guard. You could create any COM object that you want, and do .NET to JScript or whatever, and reach arbitrary execution. So one way to use it is, again, returning to Office, the application transform XML method of Microsoft Access. You basically supply an XML, you supply the transform. You could even do it like via URL, and it applies your your XSL transform to your XML file. And if you have an embedded script, your embedded script will run. So this is actually only available by lateral movement, but all you need to do is like supply the URL of the XSL sheet. You could actually, because an XSL sheet is also an XML, you could just also supply it as the source XML itself, because we don't really care about the XML transformation stuff. We just want to run code. And XML-wise, this thing will fail, so we don't really need to give it a real path to write our file or result or whatever. So we just transform the file with itself. It supposedly fails, but our code gets run, which is fine by me because I never wanted to transform the XML anyway. Another way to abuse XSLTs and lateral movement is to use Outlook's createObject method, which is basically a modification of a technique by Matt Nelson of SpectreOps. And he at first used a different COM object, which was instrumented by DeviceGuard and only available with 32-bit stuff. But you actually could use the XSL template or XSL transform objects to again reach the same arbitrary code execution. So again, you just need to create two different objects this time. One's an XML document object, the other is the XSL transform object, and then apply the transform to the document, and again, embedded script runs, you can reach arbitrary execution. And that's about it. So when I first told you about like this slide and explained it, I actually lied a bit by omission. And the omission was, well, how exactly does the scripting engine ask the host, hey, is this allowed? Because the engine itself creates our object. So it basically somehow relinquishes execution and then returns to itself. Now, the answer to this is that there is no one single implementation, which is actually the root cause of a vulnerability. Now, you could look at the disassembly, but it's actually pretty much simpler to just look at two call stacks and see what the vulnerability is about. So let's look at two call stacks. The upper call stack is showing jscript9.dll running as a scripting engine under mshtml.dll as a host. And we see that, well, there's this weird create object from prog_id function and whatever, and it relinquishes control to mshtml for this host query custom policy function, which is actually not a DeviceGuard function. It's an internal function that basically does other security checks on COM objects. And then mshtml subsequently calls isClassAllowed on itself. This comes in contrast to the bottom call stack. Here we have jscript.dll, and it just directly calls isClassAllowed under its scripting host, under cscript. Now, this means that we have two different approaches. The first approach is used by mshtml that basically says, well, I am responsible for DeviceGuard. I will call this function when it's needed. And cscript does the opposite and says, well, here's my isClassAllowed function. Here's a pointer to my function. Here you go, scripting engine developers. Just use this whenever I trust you. So both of these work, obviously, because if you'll try to run JScript9 under mshtml or JScript under cscript, both of these will work. But this depends on everybody assuming the same thing, which does not happen with JScript9. So the developers of JScript9 actually only developed it to run with mshtml.dll. But as it is an active script engine, it could actually be run with any scripting host. Meaning that while the JScript9 people just thought, well, only the mshtml convention works, meaning that our host will be responsible for doing all of the device guard stuff. So they just never implemented checking it themselves. So if we're able to run JScript 9 under CScript, we have a scripting engine that says, well, the host will do the check, and we have a scripting host that says, the engine will do the check. So nobody does the check. And everything is created without any checks, so we could just create an arbitrary COM object. Now, it looks like this. So I first tried to run test.javascript that simply runs a calculator, and we see that we have this error, automation server can't create object, which is the way that device guard says, no, you cannot use this object. And you could actually force CScript to run with JScript 9. You could supply the /e parameter that actually takes the prog ID, the friendly name, or the GUID of an object that it's going to use as a scripting engine. So this GUID is actually JScript 9's class ID. So using this, I'm simply forcing it to run under JScript 9, and as you can see, our calculator pops. So hooray for that. And we can actually use the exact same vulnerability for scrops.dll with COM scriptlets, because it implements the checks the same exact way that CScript does. Meaning that if you're able to make JScript 9 run under scrops.dll, you can again just ignore all of the device guard checks and create whatever COM objects you want. Now it looks a bit like this. You have this XML file, you have a scripting language that I've now called also JScript because JScript 9 doesn't really have a native friendly name, so you just need to create it yourself. And then what you do is actually register this friendly name in your current user registry Hive. So now we have also JScript, and then you can run the same scriptlet that I showed you before, and again, no checks are made, calculator is running, hooray for us. Now, there's actually a systemic problem with device guard, which pretty much allows you to ignore most patches that were made to any device guard vulnerability. But as I am still in talk with Microsoft about mitigating this, I won't drop this as a 0-day today, so sorry for that. So this was actually pretty much all of my bypasses, but you could still use these things even if you're not in a device guarded environment. So let's see a couple of other uses of these execution techniques. So first of all, we've actually had a couple of ways to nicely use Office for post-exploitation. So if you're getting tired of PowerShell or CScript, why not just run your whole payload in the context of a macro with, Excel running in the background? You even have a way to do this filelessly. And I don't really know any blue teamer that has seen a lone instance of Excel not loading any file, not doing, not injecting or anything like that. It said, oh, this looks really suspicious. So it's a pretty nice addition to your payload container collection. Another nice thing is while the JScript 9 vulnerability has already been patched, if you use the exploit today, it's actually an AMSI bypass, which is very simple to explain. You don't have AMSI for JScript 9. So if you're afraid of various security products using AMSI to spy on whatever you're doing with your scripts, just use JScript 9. And this has also inspired me to find another AMSI bypass, which is very similar, and it's using chakra.dll because you can never have enough JavaScript implementations on a single machine. Now, it again does not implement AMSI, but it can also, it simply threw away the scripting language's ability to create ActiveX objects, meaning that, if there are no objects to spy on, you don't really need to spy on objects. But if you're able to run it under WScript or CScript, you could actually use WScript.createObject which is an internal function that's provided by the scripting host itself to still create your own arbitrary COM objects, which will then not be looked at by AMSI because there is no AMSI. A couple of other cool things that you could do is like combine the AMSI bypasses and use Excel for macros, which you could reach through COM to simply like drive an instance of Excel filelessly to do all of the thirsty stuff that you don't want to do in the context of your in the context of your main payload. So let's do a quick conclusion. First of all, if you're afraid of these execution techniques, doesn't matter if it's in the context of device guard or not, well, they're actually pretty easy to discover and to detect because almost all of them are like command line stuff. And if you have like basic monitoring on your network that shows you processes, command lines, a bit of registry, etc., you don't need much else except for knowing these techniques to catch them. And also, I think that device guard could improve in a couple of ways. So first, I believe Microsoft should really lock down Office because it's pretty ubiquitous and you're going to have Office on your device guarded machines. And I've shown that, well, it really weakens this feature. And also, I'm not exactly sure that I've used like the only vulnerability in the inconsistent implementation stuff. So a single consistent implementation would be better. And also, if you could somehow extend application whitelisting by device guard to other stuff like Python or Java, you won't be so afraid to just put it on your machine. Because if you have a Python interpreter, you could just use it to bypass device guard because it's not instrumented. So, if you're interested in device guard, or you just enjoyed my talk, you should probably follow these guys on Twitter, and they consistently put up new stuff that's very interesting about this. And I can't really reference much prior work simply because of time constraints, but there's a lot of different research and and bypass projects that you should probably check out. So that's it for my talk. Do I have time for questions? Yeah. Awesome. Does anybody have them?
Thank you for the great talk. You touched quickly on AMSI, and all your techniques should, according to Microsoft, be subject to some extent to AMSI. You also showed us directly a few ways that it was not, we can evade it. For example, Office should be able to detect in its latest version VBA macros or scan VBA macros through AMSI. So do you know if Microsoft plans to disable the legacy modes of macros, which would not be subject to AMSI, I guess?
Well, I really hope that, yeah, they're just going to deprecate it because I have never met a person who used Excel for macros for good. But also, if you're really counting on AMSI to save you with macros, you should know that there are a couple of bypasses you could use to just not be seen by AMSI. I actually saw a pretty good talk yesterday about that. So if you ever see so you should be very interested in a talk called I think MS File Format Sorcery by Peter and Stan from Outflank.
Thank you. Maybe a second question: if do you suggested to block VBA, or the DLL of VBA? I guess that's not really feasible in many companies. Do you see a lot of companies trying to, or security products trying to go the AMSI route and try to detect your macros this way, or have you never been subject to any issue or blocking on this route?
Well, there are two different approaches. So you either want to blacklist, so you try to statically or behaviorally detect something, or you want to whitelist and just say, if it's not this one thing, it simply won't run. And these are not really so compatible. So, you know, if you're already like hardcore whitelisting stuff, macros are a serious problem because it just means that, oh, you still need to monitor every single behavior. And I haven't really seen people, using this stuff under device guard. But I think, lots of, security products today try to actually look at macros behaviorally, either via, AMSI or other means. Any other questions? Well, all right then.
Thank you.